Precalc, Chapter 7, Section 2. So we're going to solve systems of equations. Instead of using a substitution, we're going to use the elimination method, which is also sometimes called the linear combination. It's the same thing. Basically, you're just adding or subtracting the equations to solve. So again, this is a review of Algebra 2, really. So elimination method. So here are the steps. for the elimination method. You're going to multiply one or both sides of the equation to obtain coefficients that differ by sign. And really I don't care if they're different, I just care that the coefficients are the same or opposites. So how we have 3 and 3 is what I'm really looking for here. Then you can add the equations to eliminate one variable. Here I'm going to subtract our two equations to eliminate the x's. And so when I do that, I have to be careful because I'm subtracting each of these terms. So 3x minus 3x is 0x. 4y minus 2y is negative 6y. And then negative 2 minus 40 is negative 42. So if you're going to subtract them, just be careful that you're actually subtracting the values. And so then we end up with negative 6y equals negative 42. So divide by negative 6, so y is positive 7. So once you solve that equation for the variable, we can back substitute that into one of these two equations to find our other variable. And I'll just choose the top one here, so 3x minus 4 times 7 equals negative 2. So this is 3x minus 28 equals negative 2. Add 28, so 3x equals 26. And then I can divide, so x is 26 thirds, which we could say is 8 2/3, and that's fine. It's okay to have the fraction answers, rational answers. If you want to make sure that you're correct, you could take the 7 and the 8 and 2/3 and plug it into the second equation to make sure it still works for both equations. So let's go through this example again. These are our actual homework problem I'm doing for you, so it's kind of a perk to following the notes. So here I'm going to look at these. Our coefficients, we have 1x and 3x. I can't add or subtract there. 7y, negative 5y, I cannot add or subtract there. So we need to manipulate it. So I'm going to take this top equation and multiply both sides by 3. If I do that, then the system becomes 3x plus 21y equals 36. The second equation will stay the same. And then I can subtract these. And so I have 0x, 21y minus a negative 5y. So be careful, you minus a negative your sign. So that's 26y. I'm really adding there. So 36 minus 10 is 26. Divide by 26, so y is 1. After we find that, I can back substitute, and I can back substitute any equation that's x and y. And I would choose the original one that we actually multiplied by, and then plug 1 in for that for y. So x plus 7 equals 12. So then x is 5. So then we have the point 5, 1 is a solution, and again you can check to make sure that's correct. So 3 problems here. We're going to kind of do all 3 fairly quickly. I'm going to rewrite the system here. Just multiplying the top one. I'm going to multiply this both sides by 2. If I do that, I get negative 4x plus 6y equals 12. So then I'm going to take the second equation and this new first equation and add them. If I do that, I get 0x, I get 0y, so I end up with just 0 equals negative 3 plus 12 is 9. So I get this statement when I add these two together. And so we end up getting rid of all of our x's and y's. But this is a false statement. It's not true. So we'll look at that. We'll come back to that in a second. The second one, we have the 3y and 3y, so I'm just going to subtract these right away. If I do that, I get negative 3x. 3y minus 3y is 0. So 6 minus 15 is negative 9. And then I can divide by negative 3, so x is 3. I can back substitute that. I do that in the second equation. If I do that, I just get 3y equals 15 minus 3, or 12, so y is 4. So we have the point 3, 4 for that one. That worked out pretty nice. For this one, I multiply the top equation here, multiply this by 3. If I do that, I get negative 6x plus 9y equals 18. And if I subtract these two equations, I get 0 plus 0 equals 0, or 0 equals 0. And so that's a true statement. So let's talk about the first and last one here. If you get a false statement, it's not true, a false statement, that tells me that there is no solutions. And if we look at our two equations, that these are both linear equations, there's no solutions because they are parallel. They never cross. And so that's the kind of situation this would be. So this would be parallel lines. If you have, anytime you have a true statement, it doesn't have to be 0 equals 0, just any true statement, then there's infinite solutions. Infinite solutions. And the reason why that occurs if they're both lines is that they coincide, which means they lie on top of each other or are the same line. And so these are different scenarios you can have, and we actually have some terminology for that. So the terminology we have inconsistent and consistent. So inconsistent is there are no solutions. Consistent means we have at least one solution. So it could be more than one, but there are at least one. So you think about how the parabola line can intersect more than once. The other two options we have is independent and then dependent. If it's independent, it has one solution. And if it's dependent, it has infinite solutions. And so we can classify them as independent or dependent or inconsistent and consistent. So the A, where we had it being false and there was no solutions, could be called inconsistent. B, there was a solution, so it was consistent. It was also independent because it had one solution. And then C, there's infinite solutions, so it's called dependent. And we could say consistent because it has at least one, but dependent is a better representation because then we know it's infinite. Okay, word problems. Students have an issue with word problems. I have a tough time with these. We're going to be practicing these throughout the chapter, but we'll do two tonight. So a man in a boat can row 8 miles downstream in 1 hour. And he can row 6 miles upstream in 3 hours. So how fast can the man row in still water? What's the rate of the current? So when I have these word problems, a lot of times I try to figure out what my variables are. So I have C, which is going to stand for the actual current, how fast the current is going. Then R is going to be the rate at which he can row. So now I have the variables, I have to think about what's happening in the situation. And for the situation here, we know that using some of our basic like physics or basic science, distance equals rate times time, a formula we should know. And so that we know that if this individual, we do not know the rate, but we know the time is 1 hour. And so if he is going with the current, it's the time is 1 times the current plus the actual rate he's rowing. So 1 times the rate is going to equal 8 miles, his distance. Then we know that 3 hours, he can go 6 miles. That's rate time, or the time times our rate equals distance. If our rate here is going to be going with the rate at which he's rowing minus the current, because he's going against the current. So it's kind of like your vector stuff in chapter 6, where is the vector going with you or against you? Are you adding or subtracting when we did the airplane problems? And so then if we actually distribute through, so we get C plus R equals 8, and then I'm going to put them in the same order, 3R plus a negative 3C equals 6. There's your system you would solve. So that's an R right there. And so then we solve that system. And so I'm not going to go through all the work of solving it. I'm just going to talk about how you set up the problem. You should be able to solve it. So the next one here, you have $10,000 to invest in 2 simple interest funds. One pays 8%, the other pays 6%. How much should you invest in each fund so that the total annual interest is $720? So we have 2 investments, so we can just call them A and B, 2 different investments, simple interest funds. So we have 8% we get on 6% interest on the other. So I take the interest I get for the first one and I add the interest I get in the second one, and I know the interest I should get is 720. That's what it says, 720. Most students can write this one. It's the easier one students forget here, is that we have 10 grand here to actually invest. So the amount I'm putting in A plus the amount I'm putting in a B has to equal 10 grand. And so this would be our system of two equations to then solve. And a little trick for this one, if I'm solving this one, I may multiply this top one right away by 100. If I multiply by 100, it might change these coefficients so it's no longer decimals. And so that would work. You can also multiply so they have the same coefficient. Multiply this by 100 and the bottom one by 8, and then you can subtract. So it's one of the easy ways to solve it. So if you want to keep solving those, here's the solution for this one. If you want to keep trying that, you should find 4,000 and 6,000. That's the amount you're investing in those two funds. In the previous one, for the problem you're rowing, you should find values of the man can row 5 miles per hour in still water, and the rate of the current is 3 miles per hour. So those are some good examples to look at. You will have some of those on quizzes and tests for sure. So there's 7.2 and the problems you need to be doing for the lesson, and we'll see you tomorrow.